Hello everyone, welcome to Datum Learning. On this channel we talk about data and everything related to it. So in today's video we are going to solve linear regression with Tensorflow. We are going to look at an easy example. We'll develop our own data set and then we'll do linear regression on that data set, and it's going to be really fun. Okay, so let's get started. In this video I'll first explain the code here, but I'll also explain each and every cell of this code in the PPT, so you need not worry if you don't understand anything over here. Okay, so these are the imports: numpy and TensorFlow. Matplotlib is used to plot graphs and stuff, and these are to remove the warnings. Okay, so the first thing is we are going taking np.random.randn, which is basically normal distribution random numbers. We are taking 100 of them. Okay, so this, you can see we got 100 random numbers. Out here we are trying to make a line, or rather we are taking every value from here, like the first value from here, plugging it here, and multiplying it by 2.73 and adding 1.75. So do for all the elements one by one. Okay, I'll explain all of this in the slides, but just take a look. Okay, so let me play these ones also. This one, and yeah. So you saw that our values are printed. Okay, so this is how you plot a graph in Matplotlib. So you can see this graph has been plotted. It's a straight line, obviously, because we didn't add any noise. It's just taking some numbers, multiplying it with one number, adding another number, and plotting it. That's it. Okay, there are some interesting things that I'll talk in the slides about this graph. Now what we're doing, we're adding noise. Okay, so we are adding noise, so obviously now, and x data will remain the same, but y data will change. So you can see here it is 0.29 y data, and here y data is 0.26. so obviously noise has been added. Again we'll plot that. Just now you saw that we got a very beautiful straight line here and without the noise, but now you can see that there is some noise, and now it becomes a regression problem. These are the variables that we need to learn. This is the weight and this is the bias. I'll explain all of this. So basically since we have only x data, that is only one unknown variable, so this my is equals to mx plus c will be a linear regression hypothesis. Okay, so don't worry about this one. You plot the graph, and then with the this you can see 0.98, 0.85, these are values initialized by me, so they are random values. Okay, any value you can take your wish. So whatever value you take, you'll get a graph line like this. So 0.98 means this line has the slope of 0.98 and an intercept of 0.85. Okay, this is the important thing that I'll have to discuss in the slides, but what this basically is doing is finding error. If you need to understand error, my second video in this series explains in detail what error is. Gradient descent, this is the third video of the series. So yeah, you have to go learn all that in order to understand, but again I'll go through all of these in slides also. I'll just explain. And this is a global variables initializer. This is used in TensorFlow, where you need to initialize variables. Okay, this is where the actual learning takes place. 50 epochs means the whole data set of 100 will be run 50 times. I'll explain all that. And train is basically, you can see train over here, and train means optimizer, which is this one, dot minimize error, and error is this function. Okay, and you can see, okay, there's one important thing to note over here, that as your training happens, your error needs to decrease. So see, error is decreasing, and your random values that you initialized, okay, you initialized by 0.98 m. Now m has become 1.3, means it has come closer to the required value, which was of you can see over here, the required value was close 2.73. okay, and at the end you can see we are almost close. Okay, we'll never be close enough because we have noise. So this is the this is a really good fit. And 1.74 b was actually, I think, 1.75 earlier. 1.75, yeah. So we are doing a great job, and our error is reducing. And you can see over here 2.56, obviously 2.56 is a good fit to 1.75, and you can see we have got this particular graph, which is a very good fit to the data. Okay, let's go to the slides now. Okay, so we have come to the slides, and our today's topic was linear regression. And as I told you, I'm going to explain each and every cell, so if you can open your notebook alongside, it will be very very helpful. Yeah, so this was np.random.randn. I'll definitely make a video of what is randn, because it's a Gaussian, it's a normal distribution, which is same as the Gaussian distribution, same name, actually different name, same thing. This is actually giving you 100 numbers. Okay, so I'll explain this in another video, but just think for now this gives you random numbers, whatever you specify. Okay, so 100, so 100 random numbers, you can see you got. Okay, so this was a second what to say cell. In this you are taking each and every element from this was the same as the last slide, x data, multiplying it by 2.73, taking, oh yeah, you have to take every number, multiply it by 2.73, then add 1.75, which is this, then assign it to y, and this will be equal to 2.58, and you can see this is our y data, okay, which we got. So take this number from start, multiply, add, get this, and this is what we got. Okay, and do it for all the elements. Okay, plt.scatter is just used to scatter the things. The important thing that I wanted to mention is you need to understand that since even if this is a straight line, most of the values are concentrated. This is because due to the Gaussian nature, and this is what we'll take another video. I'll explain that in the different video. It is not uploaded right now, so don't go. Maybe sometime later I'll upload it. Yes, this is how you get your numbers. Okay, so the next one is y data equal to, and yeah, this is in the last slide you saw that we got a perfect straight line, and we had only this much part. Okay, till 1.75 we did not have this. Now we are trying to add some noise. If you look out here, this is 0. This basically is the mean, and standard deviation is 1. I'll explain that in a different video. I told you I'll make a video on Gaussian distribution, and again this will give you 100 numbers. Okay, so now you add the same x, because we are not changing x, we are changing y of data, and you'll get a different y. Okay, so this is actually different from the previous y data. Now this is again scatter, and the best part is now this looks like a linear regression problem because the numbers are not in a straight line. Okay, there's one thing to understand: random numbers are random in nature. Obviously it makes sense since it's called random. So your graph may be a bit different, but at the end of the day the learning will be the same. Okay, now this is since we have only x data, right? We have only x data, so we have only to learn two variables: m, which is the weight, I'll explain, and b is the bias. So this is the straight line equation: y is equal to mx plus b. Here we have m, which is the slope, which is initialized to 0.98. This is the initial value, and this is a random value. Okay, so you can do you can play with any number over here, doesn't matter. And b is the intercept. Again, this is also initialized to 0.85. You can take any number your wish. So m is the weight and b is the bias. So most of you are confused what is weight and what is bias. So this is what your weights and bias look like. Okay, now need not worry about all of this. Even I got it from what to say, Stack Overflow. But the thing is, this was the first line you saw previously also, and this is basically a way to plot the line. Okay, so you are taking a data point, taking 2 points, and then doing a linspace, which is basically 100 means from here to here, in between equal distance, 100 points will be taken. This means that much. Okay, and you are plotting it. Now this is the important thing. Okay, and from here I need you to stick, because this is the main part of the learning linear regression. Now if you remember from my second video, what was error? Error was basically the residual, and you had used to square it. Now see one thing over here, it is saying for x and y in zip x data. Now just remove this zip and everything. Okay, just keep it, but understand that this will run for 100 times, because x data is actually 100 to say 100 values were there in the x data. So for each value in x data, okay, what happens, this was the graph. Okay, if you remember, and m and b will be, I'll explain this one. Okay, just understand that this loop will run from 1 to 100 times, because x data was 100. It had 100 elements. So let's assume it will take x of 0, which was this. Then it will try to find m into x of x data of 0 plus b. M and b, this is important, m and b will be the values at the particular epoch. Now epoch is something I'll explain after 2 slides. Okay, but understand m and b will change for every epoch, and this will make sense. And what was error? Again I said you, the whatever you calculate and the true what should be there, you take the difference and find the square. Okay, and total error will be total error of the previous, means all 100 times it will run, no, but this will calculate only for one time. So you have to write over your total error equal to 0, you have to initialize and then add every small error to the big error. So at the end of the day, you'll, means at the end of the epoch, you'll get the whole error for the whole epoch. Now epoch is something I'll explain next slide. And yes, gradient descent optimizer, this will be in video 3. Yeah, this will be you need to type datum learning S1 E3. So this is series 1 and this is episode 3. Okay, not yeah. So what this is something that is explained in the video 3. Even you can understand that a gradient descent is an algorithm that tries to minimize error. Okay, so this whole thing is actually trying to minimize the error. Error was something that we looked in the last slide. And this I don't need to worry, this is TensorFlow specific. It is just initializing the variables. I'll make another video on the basics of TensorFlow sometime later. And this is where the epochs come. Okay, 50 I have taken, you can take any, doesn't matter, but make sure it's a little bit large so that training can take place. But remember, anything above 10 is fine. Okay, so or maybe above 20 is fine. Okay, to be safe. So what happens is, for I in range epochs, so for this will run from 0 to I'll explain like each and everything in very like slowly and so that you guys understand. Okay, so this will run from 0 to 50 because it's range epochs, which is 50. Inside the loop it will call ses.run train. Forget about ses.run, you need to call train how many times? 50 times. So let's assume this is called first time. So what will happen? We'll go back. Okay, see, train was called, what was train? Optimizer.minimize error. So this was called, everything is fine, but it is calling error, so we'll go back to error. So this thing, okay, so for every epoch this thing will be called, for every epoch this thing will be done. What I have explained means for every epoch. Okay, what is this? Okay, like for example, x data of 0 equal to 0.388. So 0.388 will be somewhere over here. So if you need to find out y, you need to first multiply what to say, your 0.388 wherever it is crossing the line, that particular line. Then you go over here, you will get your, what you'll get? You'll get a y hat. Okay, and then you find error and then you do total error. Now there were 100 values, so obviously 100 times this will have, and you'll get a total sum for one epoch. Okay, now come back. So what will happen is, this was the initial line, you will make an update. What you can see, this was green line was the previous line, yellow line is the updated line. Okay, now I'll show you how the update became. So this was the thing, our code cell. See, first 1.3 was 1.3 is the m in the first epoch. If you remember, we initialized it with 0.98. It is gone up 1.3 because it needs to go to 2.7, which was our initialized at the start, which we initialized, because that was something that we wanted, right? So we want this value m to go to close to 2 points, I think it was 7. Okay, so and b was b is right now 1.000 1.002, and it needs to also go to 1. Actually m was 2.76 and b was I think 1.75. Okay, and the most important thing is error needs to reduce. That's why we are here. Error needs to reduce, and you can see the error is reducing. It will never go to 0 because our data set is not perfect, and it shouldn't be perfect so that we can use machine learning. Otherwise there is no sense of using machine learning. So what you see, our values of m are going closer to 2.75. Till 50 it will, I think it will go. These are only I think 22 numbers. I don't know how many are there. And again this is also reaching 1.75. It has already reached 1.73, and this has also reached kind of 2.55. So we are already close. It will never be equal to what we want because noise is there. Fine. So if you see, for every epoch, so this was our random one, we went to a better one. You see, the golden one is better. Now again you get a better one in the second epoch. So you see, a 1.3 smaller slope. Black line, as you can see, black line has more inclination, so it has greater slope. It has, black line has slope of 1.55, and an intercept of 1.2, and error has reduced. Because why error has reduced? Because we are much closer to the data now. So at the end of the day, what we want, so yeah, after the training we got this slope, and we got this intercept which is close enough to what we expected, which is close enough to 2.73. We'll never get it equal because we have noise. 1.74 is actually close to 1.75. And at the end, when you plot, okay, you'll get the perfect line for 50 epochs. Okay, so this is how you, I explained all the lines. Don't worry about this particular, okay, np.linspace. When like if you just practice your own code and stuff, you'll get all of this. You don't have to remember. Also, Google is there for everything. Okay, so that is the end. But there's something that I need to tell you. I have actually given in the description why you should subscribe, because I think you need to subscribe so that it's beneficial for everybody. Second, you need to comment because that is more beneficial for everybody. Okay, so thank you. Bye. Thank you.